All right, so today we're going to talk about how to do some of our transformations using our construction tools, right? We've talked about how to perform these transformations using rules with a coordinate plane and that kind of thing. But now we want to use our construction tools. First we're going to take a look at is the dilation. First thing that I want to kind of talk about is the fact that, and so in your notes, in your note packet that you've got, we're on the page that has the paper clips at the top of it. And so if you look at these paper clips, one thing that I want to make sure that we pay attention to is the fact that in a dilation, you can draw a line from the center of dilation, and that line will go through both the pre-image and the image point, right? The pre-image and the image and the center of dilation are all going to be collinear. And that's true no matter what shape we're talking about, okay? So we're going to use that idea to help us do our construction dilations, right? So if that's going to be true, and that will always be true, the center of dilation, pre-image, and image should always be collinear. Excuse me, sorry about that. So if we go down to the first example here, this quadrilateral DEFG, actually is a parallelogram, and we're going to use that idea of the center of dilation, pre-image, and image on all being collinear to help us out with these dilations. So in this particular example, we want to use point D, we want to use vertex D as our center of dilation, right? That means that I want to construct a straight line that goes from the center of dilation through a pre-image, and I'll use E first. So E is our pre-image. And so I'm going to draw a line from the center of dilation through point E. And what that means is somewhere on that line or line segment, we should be able to find E prime, right? Now, how do we go about finding E prime? Well, we have to remember that dilations create similar figures, not congruent figures. So what I want to do, especially in this guy, in which our scale factor is supposed to be a 2, that means I'm trying to create an image that is twice as big as our pre-image, which means that any length in our pre-image needs to be doubled. We need to find a length that's twice as long for our image. Well, length, remember that with construction, the way we measure length, not with the ruler, is with our compass. So with our compass, we're going to put our needle on D and open up our pencil to point E. That's us measuring the distance from D to E. And in order to double that distance, to make our image twice as big, I just keep my compass open the same amount. I move my needle over to the arc that I just made on E, the intersection of that arc and my line, and just use the same measurement to measure again an arc on that line, right? That means that that is where E prime should be, right? And there you go. Now you could erase, I suppose, the rest of this. That's okay, I'm not going to worry about that. But the length of D to E prime should be twice as long as the length from D to E, right? Now I want to do the same thing for all of my vertices here. So now I'm going to draw a line from point D, which is my center of dilation, through F, and I'll try to make it as long as I think I need to. If I don't make the segment long enough, I'll know when I make my second arc, and I can always go back and make that segment longer, right? So now I'm going to measure the distance from D to F. And now that I have that distance, I'm just going to double it. So my needle on the first arc, make a second arc, that's where F prime is. And do the same thing for G, right? So from point D through G, measure the distance from D to G, arc, and arc. And there is G prime. Right? And at this point, we want to finish connecting in our new parallelogram. And there it is. D prime, as you imagine, since D is the center of dilation, is not going to, it's not going to move off of D. So D prime is going to stay right there. So now D prime, E prime, F prime, G prime is our parallelogram that is now twice as big as our pre-image parallelogram. Okay? Now, your second example is just what you would do if our scale factor were now a factor of 3, right? And we can even consider this, and I know that your notes talk about dilating it with R as our center of dilation, but we can actually even come off of the shape and do a center of dilation. Let's say if our center of dilation was right above this line that was created for the box, maybe say right there, right? Maybe that, make that our center of dilation, right? So maybe call that point P. The process for creating our dilation is still going to be the same. I still want to draw a line from my center of dilation through my pre-image, right? And now I need to make the length in my image not twice as long, but 3 times as long. This doesn't get a whole lot more complicated. You simply measure out your distance like we did the first time, arc, then place your needle at that arc intersection, do another arc, but then we have to do it again to create a third segment, right? And so now R prime would end up there. And of course we would do the same thing for all of our vertices. There's from our center of dilation to our next vertex. Maybe open that up just a little bit more. Then make another arc, and then make a third arc, never touching our compass to make sure it stays open the same amount. Now this is also labeled R, which is a no-no, but that's okay. So now R prime barely gets in right there. And now we want to go to S and do the same thing for S. This is maybe even bigger. So we'll see, probably, I mean, it should be bigger. Oop, needle on P, open up to S, and now we've got to do this, measure this out 3 times. There's 1, 2, 3. So obviously it did not make my segment long enough. So now I gotta go back in and extend it. And so now S prime is here. And now connect in your prime points. And so there is your dilated triangle. Okay? So that's your dilations. Now we got to talk about your rotations. If you flip back a page to the beginning of your day 2 notes, that's where our rotation started, and we had a couple of examples in here where we wanted to rotate using our tools, right? So now this rotation, we're supposed to be rotating about P at 120 degrees. Okay? And you have to remember that the way we defined our angle of rotation was if we were to draw a ray from our center of dilation to our pre-image, and then a ray from our center of dilation to our image, those 2 rays should make an angle that is equal to our angle of rotation, right? So now our trick is to not only measure distance, because remember that rotations, unlike dilations, are isometries, and so distances, lengths, and angle measures should all be maintained. They should be preserved, should have the same, right? So we're going to create some rays that are at 120 degrees from each other, and then measure some distances to make sure the distances are going to be the same, right? So that's our process. So from this center of rotation, we're going to make a ray from point P to C. And now I don't just make a ray wherever I want. I got to measure that out. Now this is the only sort of less accurate thing that we do with our construction tools, right? But there's no other way to do this. We can't construct a 120-degree angle, so we're just going to have to measure it. So the way we measure it is we put our center of rotation right there in the hole of our protractor, and then we can line up the ray with that straight line on the protractor. If I just turn this to get it on there. Now, if you have a different protractor, then you have to figure out how to measure out 120 degrees, okay? But there I've got it lined up. I want to rotate counterclockwise, so I want my angle to open up this way. So I'm going to use those bottom numbers until I get over to 120, and I'm going to make a point right there. Now that tells me where I can draw my other ray to where it is 120 degrees from the first ray. So that angle is 120 degrees. Now all I got to do is maintain distances. So now I want to draw a distance from, or measure a distance with my compass from point P to point C. Right? And that will tell me what distance I need to measure out from point P to my second ray. And that means that C prime should be right here. And then we repeat the process for all of our other points. I'm going to make my first side at A. Then I have to use my protractor to measure out 120 degrees. Opening up counterclockwise, I'm using the small numbers to measure. Let me see if I can't get everything in here. There's a 120 degree mark. Right? Now I've got to measure the distance from P to A. And then carry that distance over to the other ray. So A prime should be here. And now I got to do the same thing for B. So protractor down on that ray, measure 120 degrees, which is there. Now draw a ray. And then measure the distance from P to B. And with that same compass open being the same, there's where B prime should be. And now use your straight edge to connect all those intersections. And this should be your right angle. And that's it. That's all there is to it. We can always rotate clockwise if we wanted to. That just means that we would measure, we would come down here and put our compass down to where our angle would open up clockwise. Okay, then we use the top numbers on this guy, but most of the time our rotations are counterclockwise. Our rules are in terms of a counterclockwise rotation, so we'll just keep it that way. So that's it. I know there's another example in your notes. I don't know that we need it because now we're just going to rotate 50 degrees. So instead of measuring out 120 degrees, measure out 50 for each of those. Okay? Any questions, please feel free to stop by and ask them, and we'll clear them up. But you've got some transformations to do with your construction tools and your homework, so get that done by next time.